Hello, my name is Rob Reynolds. Welcome to Business Calculus, Chapter 4, Section 6, the last section before our chapter test. Today we're going to learn about exponential growth and decay. There's no derivatives in here. We're just doing some word problems, basically using this formula where you've seen this before. A is the amount after so much money principal has been invested. E is a constant. R is the rate, and T is time. Or you've seen exponential growth models as this PERT formula. And so today we're going to be talking about C, which is the same as the P, the K, which is the same as the R, and then the amount will be the Y value, the amount after. You plug in X and solve for Y. So today we're going to be talking about real life situations, maybe where you could apply this. All right, so remember the rate of change just means dy dt in relation to time, and you have some constant y, and we're going to be using this formula. Let me give you an example. Oftentimes you deal with half-lives, so the rate of decay is a half-life problem, and then there's all sorts of charts that will tell you how long it takes something to decay half of its life. So here's example number 1, and it says radium, so we're going to use the chart for radiums, and we find out that it takes 1,599 years for it to decay. So we're going to start right there. Either you could use the formula for PERT, or you could use the book's formula, which says y is equal to CE to the KT. We're going to plug in, if it's half-life, then when C is 1, Y is a half, and that takes exactly, I'll do K, and the amount of time is 1599. So I'm going to solve for this using some logarithms. The natural log of 0.5, or the 1/2, is equal to the natural log of E to the 1599K. Again, more log properties, dump that out front, and hopefully by now you know that the natural log of E is just a 1. And our last step is to divide. So let's go solve for the rate by taking our calculators and finding K, which is the rate. And K turns out to be somewhere close to negative 0.00043335. So the formula says y is equal to, if I have 1 gram, 1 e to the negative 0.00043335 for 1,000 years. I'll plug in 1,000, and I'll get y to be close to 0.648 grams. So to answer the question, will there be more than a half? Yes, barely, 0.64 grams. So here's how the author worked it out. I think something similar, and they get the same answer. Example number 2. Again, you could either use PERT or the formula that they gave us. This time it says it starts with 100 flies. So it's CE to the after 2 days. So K times 2 is 2K. And then there's another formula over here that says 300 flies after 4 days. So over here, I'm not really sure what C is. So I have two systems I'm going to solve using substitution. So it doesn't matter which one we take. I'm going to take this one and substitute in for C. And I'm going to find a C by solving for this guy right over here. So C is equal to 100 over e to the 2k, and I'll plug that in right here. 100 over e to the 2k, called substitution. And then I'll go ahead and solve. Let's divide both sides by 100, cancel, and rewrite the base and subtract to the 2k. and then natural log both sides. The natural log of 3 is equal to 2k, and then k is equal to 0.5493. The last step is to answer the question, how many after 5 days? So after 5 days, how many will there be after 5 days? Well, let's see. First of all, I need to go find c. So 100 over e to that 2k, and there's that k number, which will get plugged in right there. I'll punch that, and c will turn out to be, well, it's close to 33. So now I can write myself an equation. Y is equal to 33e to the 0.5493 t. So now all I have to do is plug in 0.5493 after 5 days. That's the amount of time, and solve for y, and y turns out to be close to 514 flies. So we first found k, then we substituted that back in and solved for c, wrote myself a general equation and solved for t. Here's the author's worked out solutions, which are posted on Blackboard. And if you haven't already, you can go to Blackboard and download a blank copy of this, and there's 514. Example 3. Since they're talking about interest being compounded continuously, instead of using the c and the k, I think I really am going to use PERT this time. It might make a little bit more sense for p being the amount of principal. And I know that this account is going to double after 6 years. So, if p is 1, then a would be twice that amount. In other words, if you let p be 1, this will be twice as much, e to the rt. So it doesn't really matter. You could have let p be 300, and then this would be 600, but then no matter what you do, you're going to get a 1 and a 2 here after you simplify. So let's go ahead and solve by letting time be 6. So 2 equals 6r, and if you ln both sides and divide through by 6, there's my rate, which is, punch it, the ln of 2 divided by 6, it's close to 0.1155, or it's about 11.55%, which I think is all they asked for. What's the annual rate? And the author has the same solution. Example number 4. We're going to say, let's see, I better read this a little bit more carefully. Let's see. Looks like this is the start value at time 0. So 100,000 is equal to CE to the 0. And then after 4 months, it drops to this amount. So let's see. After 4 months, 80,000 is equal to CE to the 4K. But I don't know what C is, but I think I can solve for C over here because e to the 0 is 1. So C is 100,000, and I'll plug that in right over here. So 80, doing a little substitution. Again, writing 2 equations, and then I'm going to plug this C in right here. Equals 100,000 e to the 4K. I'll divide this out. 0.8 is equal to e to the 4K, and ln both sides. And divide through by 4 to solve for k. And I think it's going to be close to negative 0.558. So then I could write an equation. I think I have everything I need. I got C, I got K, and I can answer any kind of question you want. So y is equal to 100,000 e to the negative 0.0558t, and let's see, it's another 4 months after these 4 months, so I think that's a total of time to be 8 months. So punch letting time equal 8 and see if you don't get around 64,000. So again, writing two equations. Good. The author got the same thing. Yep, and time to be 8. Good, good, good. And there's a model of it. Good, around 64,000. So you can try number 5. It says that it's passing through 2 given points. I think this question's on your quiz. And here's worked out solutions. You can practice that by going to Blackboard and look at the workout solutions and practice that. Number 7, you can practice on your own as well. Although it's the first problem that gives you the, maybe I should work out, maybe I should just start number 5. So given 2 points, we're going to write the two systems again. So when y is 1, we got CE to the k, and we've got there's a 1, 1, 1. There's the x, so the rate. And then the second formula is when it's a 5, well, you can't go wrong. It's 5 and 5, CE to the 5k. Where this is the x and this is the y. I wish they would have done something different. So over here we've got CE to the k equaling 1/5 CE to the 5k, because 1 is 5 times the 5, or the 5 is 1/5 of 1. And then solving, I can divide by, let's do CE to the k and cancel. In fact, I could multiply both sides by 5 here, so I'll cancel the 1. So I'll get a 5 is equal to CE to the 5k over CE to the k, and I'll rewrite the base. And subtract the exponents. So let's see, the c's cancel, so rewrite the base. 5k take away 1k is 4k is equal to 5, and I'll ln both sides equals 4k and divide through by 4. So take the ln of 5, divide by 4, and see if you don't get 0.4024. Oh, this is a long problem. So then we go back, y is equal to CE to the 0.4024t, and I can plug in a 1 and another 1 here and solve for c, and see if you don't get c equaling 0.6687. So then the final solution is 0.6687 to write this equation, e to the 0.4024t. Oh, that was rough. What did they do? Yeah, well, they did get k. So yeah, 5 is equal to... All right, so here's how the author worked out. It looks like we got the same solution. For this one, if this problem is going to ask you to do a verification that the rate really is cy. So let's start with the only thing that we know. Y is equal to CE to the KT. And it does tell me that Y is 10. So I'll plug that in. 10 is equal to CE and 10 when time is 0. So e to the k times 0. So that's c e to the 0, or c times 1 equals 10. And I do know c is 10. So this is the rate, and we're letting A is equal to PE to the RT. We're letting our rate be K, and our rate is 2y. So I'm going to plug that in for my rate when C is 10. So y is equal to 10e to the rate, which is 2y. And really, the rate is just doubling the y function. So the rate is 2 amount of times. So they're going to say if this is because they first asked write an equation. So if this is the equation, then they say verify that by showing the derivative. So the derivative of this thing is chain rule. The derivative of the outside, well, 10 is a constant, e to the 2t, and then the chain rule says to the derivative of 2t, which is just a 2. And notice that this part right here, this 10e, is y. And so I could just substitute all that. It's back substitution. So I could say y prime really is 2y because all of this is the y value. And that's what they're saying. Aha, the rate really is doubling the y value. Oh, I'm glad I worked through those. And then 11, 12, and 13 are going to give you a chart and asking you to plug in for some missing items. And here we have to find time after 1,000 years and 10,000 years. So I'll set this up real quickly. The video is getting a little bit long. But again, just starting these sometimes seems to be the difficult part. Solving them gets to be a little bit easier. So for this first one, we know the initial amount is 10, and the rate is not given. Oh, but we have this half-life thing. So do you remember on a previous example we solved for the half-life, the rate or the k value was the ln of 0.5 divided by 1599. We'll go back and check that out because that's some decimal. I'll just say decimal to the t. And then I'm just going to let for this number 11, then I just let t equal 1,000 and then let t equal 10,000 and solve. For number 12, this time they gave me one after is the 1.5. So 1.5 is equal to CE to the same rate, this guy. I'll just say that decimal again. Let's call it decimal 1 because it looks like the decimal 2 is going to change in number 13. CE to the decimal 1 for 1,000 takes 1,000 years for it to get there. So they gave me 1,000 is for the amount of time. And this time you're going to solve for C, and it will turn out to be close to 2.31. So then you plug everything back in and solve for, let time be 10,000 years. For number 13, looks like the rate's going to change just a little bit. So it's going to be y is equal to CE to the natural log of 0.5, not divided by the 1599, but now it's the 5715t. So the decimals changed a little bit. And this time it's going to be y is 2 grams after t is 10,000. So you're going to let time be 2,000 and let y be 2 grams. And plug in and solve for C. So 2 is equal to CE to the all of this with the 10,000. And I think C will turn out to be around 6.73. And then once you do that, you can start writing equations. Y is equal to 6.73 e to that, but we'll call it decimal 2. And then you could solve for the 1,000 because that's the block that we don't know. So to solve for this guy, I'm going to let time be 1,000. And then I'm going to crunch this and get an answer, and I think it's around 5.96 grams. So it's kind of interesting. Always start with just that general equation, start plugging in and solving for the things that you don't know. I hope you found this video helpful.